Folks, welcome. Hello. Welcome to AMS Weatherband's latest webinar, How Time Flies, 10 Years Since Superstorm Sandy, with David Novak, Gary Zakowski, Ornella Nano, and moderated by Erica Groche. Now, before we begin, I would like to address some of the ground rules for our webinar today. First, if you have any questions during the webinar, if you'd be so kind, please put them in the Q&A option. If you look at the bottom of your Zoom screen, to the left of the chat button, there is a Q&A button. If you have any questions, please put it in that option, because that's where we're going to corral all of the questions so that we don't have to, sort between questions and comments and whatnot. So all your questions should go there if you want them addressed. Don't put anything in the chat. We will also have some specific time for questions from the audience after the interview, but according to however Erica chooses to go, we might answer it during the program. So hang tight. And speaking of Erica, first I'd like to introduce today's moderator. Thank you, Erica, for joining us today. Folks, Erica is a certified broadcast meteorologist. After 18 years on camera, Erica stepped behind the scenes to become the broadcast manager for the AccuWeather Network in 2021. Now, before joining AccuWeather, she was the weekend evening meteorologist for WNBC in New York City. She also previously served as an on-camera meteorologist for WPVI, the ABC-owned station in Philadelphia, and WUSA, Washington, D.C.'s CBS station. Erica served as the AMS council from 2019 to 2022, and she is the incoming commissioner on personal affairs. She has served as a panelist, moderator, or presenter at more than a dozen AMS conferences and symposia. In 2019, Erica was a delegate to the World Meteorological Organization's World Congress, CG18, and her work with the WMO continues today. Erica received the Certified Broadcast Meteorologist designation from the American Meteorological Society in 2012. She has a Bachelor's of Science degree in meteorology from Penn State University, and she was named a 125th anniversary fellow of her alma mater's College of Earth and Mineral Sciences in 2021. Erica, the floor is yours.
Thank you so much, Gideon, and thank you everybody for joining us this evening for what I think is going to be a fascinating discussion 10 years after Superstorm Sandy made landfall in the East Coast of the United States and brought impacts to about a 1,000-mile section of the eastern seaboard of the United States, and of course inland from there. So we have a great panel of guests to talk about that today. And I'm going to start by introducing Dr. David Novak, who is the director of NOAA's Weather Prediction Center. The WPC serves as the nation's premier center for forecasting rain, winter storms, extreme temperatures, and relaying the big picture weather story. If you've ever been to their website, you'll see that map analysis there right on the home screen. The center is also a catalyst for collaboration among National Weather Service local forecast offices to make sure that messaging and forecasts are consistent, and the center is interwoven into the national readiness framework for extreme weather. Throughout his career, Dr. Novak has been a champion for connecting emerging science to operational applications with a focus on extreme weather events. And when Sandy was making its way toward the East Coast, Dr. Novak was the development branch chief for the National Weather Service. So thank you for joining us today, Dr. Novak. Gary Sadowski, and I'm sorry, I hope that I pronounced your name correctly there, Gary. I've been a fan of Gary's work for a very long time, dating back before my days even at WPVI in Philadelphia when he was working at the National Weather Service office in Mount Holly, New Jersey. And since his retirement from that office in 2016, Gary has done consulting work in forensic meteorology, aviation meteorology, operational meteorology, and professional development training. He's an officer on the board for the New Jersey Emergency Preparedness Association, and he is a member of the American Meteorological Society. Thank you for being a member of the AMS, the National Weather Association as well, and the New Jersey Association for Floodplain Management. Gary has been recognized as a Hurricane Sandy hero by the Newark Star Ledger newspaper and received the Weather Hero Award for 2012 from the Weather Research Center for his work during Hurricane Sandy. And if it wasn't obvious, Gary was working at the Mount Holly office when Sandy was making landfall, and that office is the local FO for the Philadelphia region. Thank you to all of our panelists for joining us today for this conversation. And I did get a Facebook memory earlier today. You know, when you check your memories on Facebook, I don't know if anyone does that on a regular basis, but on this day 10 years ago, Superstorm Sandy was still a hurricane in the Caribbean latitudes, and its path was uncertain. The projected path had made that westward turn. And at this point, I think we were 3 days out from landfall, and we were wondering just where along the coast it was going to eventually make landfall. So I'd like to start with Gary, if you don't mind. What was that like at the FO in Mount Holly? It was almost 100% certain at that point that landfall would be in your, it's called the CWA, the County Warning Area, for those of you who are not as well versed in National Weather Service speak. So what was that like in your office, Gary?
Well, it was an incredibly stressful time and I'm sure that's true for everyone, you know, that is on this panel and so many others who were here 10 years ago. You know, we had actually seen a ramping up of phone calls to the office basically a week in advance, on that the Monday, the Sandy made landfall on a Monday evening. The preceding Monday, we we're already seeing phone calls coming in above average with curiosity about this storm, and then on the next day, Tuesday, we started with our first briefing package from emergency managers and other key officials, and that set like a new record, because that was like about 5.5, 6 days before Sandy landfall, and previously we'd done that maybe for a winter storm, maybe about 3 days in advance. So by 3 days before landfall, the place is just hopping. We are now booked solid with briefing calls for emergency managers. We've got additional staffing lined up. We have some staffing, National Weather Service for active events, moves people from other offices, more inland, or not inland locations, but other offices that are familiar with the service programs of the coastal office, but are not experiencing active weather during the time of the hurricane, and send them to our office. So I'm doing briefings. The staff is doing the forecasts. I'm worrying about, do the people coming here, do they have their hotel rooms lined up? So it's a very, crazy. And also you're worrying about your employees. I've got to cut people loose so they can go back and secure their home, make sure their family members are going to be taken care of if they're going to be at the office during the height of the event. So that's just some of what went on, but that's what comes to mind. What first comes to mind with your question.
So Dave, you were not in the line of fire as far as the storm impacts where you were physically living at the time, but that doesn't mean you weren't involved. You were very heavily involved in getting ready for this storm. So what was happening in your area?
Yeah, so I was at the National Centers for Environmental Prediction in College Park, Maryland, so just outside of Washington, D.C. And what I remember, I think we're having some sort of on-site meeting on Tuesday. So I think Sandy made landfall on a Monday. It was almost 6 days in advance, and it was just kind of this. Folks are. I guess we had phones. I'm not sure we had smartphones necessarily back in 2012, but there was this unease in the room, and just as the new model guidance started coming in, at some point that meeting kind of transitioned from the meeting to, we've got to get prepared for a major storm, and things certainly ramped up. As the Weather Prediction Center, we have a variety of missions here. So the rainstorms, Superstorm Sandy certainly had a lot of rain. It was also a winter storm, right? So, and that's a key part of WPC's mission. And then we we're not only the backup to the National Hurricane Center, but we also handle the system once it comes inland. We are the official voice of the impacts, of the inland impacts of landfalling tropical systems. And so being a development chief in the Weather Prediction Center, we were early on trying to organize, make sure we had staffing. It really was kind of, from a human perspective, it was this sinking feeling of the awfulness of what was about to unfold. From a weather weenie perspective, it was, you think about a hurricane and you think about a snowstorm, and you think, as a young meteorologist, you're like, well, what would happen if those two mixed? Well, unfortunately, I think that's what we saw with the Superstorm Sandy was, both the snowstorm aspect and the hurricane aspect. And obviously with, it still stands as the fourth biggest US disaster. I looked up the stats here, fourth. So behind Katrina, Harvey, and Maria. So anyways, I think there was just this sinking feeling, if you will, of watching this through the week, and just a ramping up of preparedness for our partners.
Excellent. I see we have a question in the Q&A. I have a couple more overview things that I'd like to ask our panel before we get into that. But if you do want to ask a question, just a reminder from what Gideon told you, please use the Q&A button, and you can type in your question there. One of the pieces of information that was such a big hot button issue after the storm moved through was that the European model made that turn before the GFS, the American main forecast model, made that turn to the west. So I'd like to hear from our forecasters. What was that discussion like in your FO and at NCEP? What were you all wrestling with?
Yeah, I can go ahead and start from the bigger picture. So one of the key points, it got to be this versus American model versus European model. Gosh, the official forecast was among the very best of any of these models, of the European or the American. And part of that was because the forecasters on both the medium range desk here at the Weather Prediction Center and the National Hurricane Center, they are using ensemble information. So we're looking at over 200 ensemble members, individual members looking at different perturbations of initial conditions or different physics. And, there was certainly this bifurcation. I mean, some members, even some amongst the GEFs, the global American model ensembles, took the left turn. And some amongst the European took it out to sea. And so it really was this, there was a natural uncertainty in the atmosphere, a bifurcation of would it or wouldn't it, get caught up with the upper trough to the west. And so I think, this kind of highlights, even as we're here, 10 years later, the important role of the human in terms of synthesizing all the various numerical weather guidance and, making sure it's consistent and accurate and the very best forecast that we can provide to the partners with appropriate and appropriate expression of uncertainty. And so understanding that, hey, this is our most expected system, but you got to understand that there's some uncertainty. Scenario A might be out to sea. Scenario B, might be even further south along the coast. So yeah, somehow it got to be that narrative. But one of the other aspects of that, just briefly, it's a collaboration. So one of the really neat things that happens, I think, in the modeling world is this recognition that there are very good things about some models, and each model has their quirks, if you will. And so, and that we need to work together on making, these best modeling systems we can for our national interests. So, yeah, there, I actually think Superstorm Sandy actually helped strengthen some of the collaborations between the international modeling centers, because this was just a very difficult predictability situation.
And I agree with everything Dave said, and I'll just toss a few things in here just to kind of reinforce some of the points he made. Going back all the way to like a week before landfall, we even saw, I'm active on Twitter since after Hurricane Irene, which was in 2011. And so short, so like a year before Sandy. And I could see a discussion on Twitter about Sandy's potential track after it developed, on that Sunday, 8 days before landfall. And there was clearly people were referencing some of the ensemble guidance, some of the different model solutions. It was more than just a Euro versus GFS, so that obviously became sort of the dominant way to kind of describe the situation, the different solutions. But that clearly, the ensembles clearly were leading people to start to understand that there was a threat to the East Coast well in advance. And then, the other point Dave made was that the humans, were in the loop the whole time. Some people who spoke with me either during or after the event, who were a little agitated about why the GFS wasn't doing so well. I said, that's for the modelers to work on if that is indeed an accurate characterization. But the thing is, the humans were in the loop the whole time, and the humans, produced an excellent forecast. I am going to try to share my screen to make this point. Let me see if I got my PowerPoint up. Let me share screen, and let's get this up. Let's see what happens here. See if I can. Oops. And it didn't go exactly where I wanted it to go. Let me scoot on down.
But I was going to say, we do see your screen, so.
Yeah, I thought I had pre-positioned at the slide I wanted. So anyway, I just want to this is actually from Dave's shop. This is back when it was HPC. And this is a day 7 forecast. And so this map is valid for 8 a.m. Tuesday, October 30th. And you can see kind of a double-barreled low structure there. That's, for those, I think most know, but for those who don't, I tell back when I would, was the MIC, people say, okay, the Hurricane Center does a 5-day track forecast, but I said there's a cheat code. The cheat is that you can actually get a day 6 and day 7 forecast, because back then again, HPC and the Hurricane Center collaborate over the hurricane hotline, and if you're in the forecast office, you could hear it every day about where the best forecast would be to put a day 6 and day 7 point. All they do is put an L here. They don't have a hurricane symbol. But that's clearly Sandy. And here, that's only like 12 hours off in landfall time, and about less than 200 miles off on location. Maybe it's like 150 or something. That's a spectacular forecast, and that's just one of many spectacular forecasts that were produced both by Dave's shop and then also by the National Hurricane Center. So I just want, when people were saying, people who were like, oh, the GFS, was fooling everyone. No, it was fooling no one. I mean, I guess I would say, or no one on the operational side of meteorology. The National Weather Service, the forecast reflected some excellent skill. And where the GFS was behaving for a time as an outlier, it was kind of treated that way. And then eventually it came and joined the party. And certainly the ensemble members and the GFS were joining the party sooner than the operational model. Some of that guidance clearly indicated that there was a growing threat to the East Coast well before the deterministic GFS snapped back to the left. So I'll stop sharing my screen. There we go.
And that's a great point, Gary. And for anyone who is a little unsure as to whether we still need humans in forecasting, Sandy 10 years ago, Ian just a few weeks ago, and many, many events in between in the past 10 years clearly demonstrate the human element of the forecast. Because if we did just take one model solution, even an ensemble of solutions, and try to draw a trend line or tried to make the best fit forecast, we wouldn't be able to prepare properly, because that wouldn't provide the same specificity of information needed to make the correct decisions. I did also want to, I don't want to get like too far down the timeline with this story, but something that was discussed heavily, I'm an operational forecaster by background as well. I just happen to present my forecast on the news after I'm done making it, right? And so there were focus groups, discussions that happened after Sandy about, there were significant initiatives that were launched, not just because of Sandy, but the Joplin tornado outbreak that happened. I want to say either in 2011 or 2012. The exact year is escaping me. But the IDSS effort, the Impact-Based Decision Support Services, was born out of these events, and also Weather Ready Nation. So the Weather Ready Nation Ambassador Initiative was also in part founded because of a recognition by NOAA that we all need to do a better collective effort at conveying the impacts, the potential impacts of a storm, so that people are equipped with the knowledge to take the appropriate action. So I'm wondering what our NOAA folks think about that, and what discussions were happening on your side of things after Sandy. The lack of a hurricane warning comes to mind, but other things. I just want to open the floor to you.
I could start big picture, and then maybe Gary, you want to go, with the local aspect. Just as you described, Erica, I mean, there was this recognition that, and it became this kind of almost a mantra within the Weather Service, that I think there was a paper by Alan Murphy in 1993 that, a forecast alone, a forecast attains its value by just basically the decisions or actions that it motivates. I got
that was Murphy, 1993.
Look it up there.
You've got
the
it
point
right.
is that intrinsically a forecast has no value unless it's acted upon or helps influence a decision. And I think that was it took multiple years, I think, for that kind of cultural evolution to kind of ripple through and take hold in the Weather Service. But my gosh, my goodness, I tell you, in 2022, that is just a core belief of Weather Service employees, is that the forecast doesn't stop at the forecast. So we have to connect this forecast information to decision makers like Ronella and others, that are making critical decisions. And in fact, the Weather Service changed or added it to its mission statement, this impact-based decision support to the mission statement. I think it was about a year ago at this point. So you kind of, if you follow that through, it's kind of interesting to think of a decade, from Irene, Superstorm Sandy, particularly I think the southern, the April 2011 tornado outbreaks and such, to now, where that again, it is impact-based decision support, focus on the impacts, focus on how this information forecast can be used for decision makers and our partners. So it really quite a revolution, really, in the last decade.
Yeah, I agree with everything Dave said, and I'll add in more from a technical aspect. The one thing post Sandy that I would tell anyone who walked in the door, any phone call that was on, when they would, because people were saying, hey, what do you need? There's kind of this magical window that opened up post Sandy. A Sandy supplemental came out of Congress, so now there's money, and I just kept saying storm surge inundation maps. That was I would say that from first thing in the morning to the last thing in the evening. It was because I had rainfall maps from Dave's shop, showing how much rain is going to fall. I could generate maps showing the wind, what the wind would look like, over the region at any particular point in time. And I had nothing. What we had to do back then, that's not fair to say nothing, but what we had back then was canned maps that had been done. And actually, for up in the New York City area, where there was quite a bit of attention given, how much storm surge occurred, that had been done by the Army Corps of Engineers back in 2010. So it was relatively fresh, just a couple of years before Sandy, but it was still keyed on hurricane categories. So it's basically a map saying, hey, if you get a Category 1 hurricane, this area will flood. Category 2, it goes a little further in, there's different colors for each of the levels. And again, our part partners, we're supposed to kind of cross-pollinate between that and, the information coming out of the Hurricane Center. And the numbers didn't always match because each storm is unique, and Sandy became so huge, which was a physical driver, physically huge, that that drove storm surge numbers. Again, there were quite a bit of comments after Sandy, one from North Jersey that I got from one of our partners who still remember back when the storm surge, or I'm sorry, the Saffir-Simpson hurricane wind scale also included things like storm surge. He said that was a Category 3 hurricane. He said that the surge we got is back when the scale had surge in it was equal to Category 3. And so that, hammered home to me that we need, for each storm, we needed, maps in real time once the storm was close enough, to start producing them. Took a couple years after Sandy, but it happened, and that was, to me, that's one of the greatest technical improvements that occurred from Sandy relatively quickly. I think 2014 they started with the prototypes, and then it kept going after that. Now storm surge inundation maps are pretty much a regular tool to be used.
Absolutely. Dave, did you have something you wanted to add there?
I mean, yeah, it is interesting to think about that, Gary. That's a really good point about maybe how far we've come. We certainly have plenty of distance to go. But you think about in 2012, I did look it up. The supercomputer that we had at NOAA had 0.1 petaflop. It was 0.1 petaflop of, that's how many simulations you can do or calculations you can do in a second. Right. And now we're at 12 petaflops. So just to kind of think about, how far we've come on the.
I remember when we went to 5,
Yeah, right. And I was looking up the 1 minute GOES imagery. It was experiment. That was a big deal. They ran it for Sandy as kind of a prototype experimental on the GOES 14 imager. And then, like you said, if I remember correctly, we really did make Superstorm Sandy really did make some major changes to how we handle storm surge in terms of talking about it in terms of inundation above ground, because there got to be this, what's your reference level, all this kind of confusion there. So, and then the maps, like you're saying, that we have now the storm surge inundation graphics and other information as well. So we have plenty more work to do. Don't get me wrong, but I think it's important always to ground yourself and just as we work together, how much progress can be made over a decade.
Yeah, and as we're talking about this, I remember Jamie Rome, who is now the acting director of the Hurricane Center back in the Irene and Sandy era. He was in charge of the storm surge unit. I remember having conversations with him about what we needed, and he was just like, right now it's my staffing is 1.5 people, me and half of a contractor. That's all I've got, and that to me was a real shame, that because I think things moved faster once we just got some funding. And I took a peek at the storm surge unit webpage now, and there's 6 or 8 people standing there, posed, all working now on keeping the storm surge unit going with all the stuff that's happening now. So it is there are some really nice things that came out of the money that Sandy, the aftermath of Sandy brought. There was a lot of suffering during the event, but some of the things we've changed since then, I think, will help us for future events, whether like Sandy or really not too similar at all. It's the idea of a map is just very helpful. So, but anyway, just one of the things. And I guess since I'm talking, I'll just mention, Erica, you touched upon the hurricane, not hurricane warning. Yeah, that was a little traumatic. There's been there's at least one book written about it that pretty much described the National Weather Service's challenges there. Both the flaws and the strengths. Yeah, but I do like how it turned out during the event. We had the whole issue, and we could talk about whether we should have anticipated it better than we did. But this whole idea of transitioning storms puts a real stress on our nomenclature, and people make decisions as much based on labels as much as any technical information. So this whole business of was it a hurricane or not was a topic of some anguished discussions over the phone I had with residents in New Jersey after there was one gentleman who was livid that it wasn't considered, he looked online and it wasn't listed as a major hurricane. He said, how could that not be? And I said, you're not even going to like what I'm going to say to you next. It wasn't even technically a hurricane when it made landfall, so it's never going to show up on that list, you know, as a major hurricane, because it no longer was a hurricane. So that was, so the policy change now, I think, where you can have hurricane warnings for something that used to be a hurricane, but technically no longer, now is now the technical term is a post-tropical cyclone with hurricane force winds. It can keep a hurricane warning. And I think anything to hold down the label switching, the warning label switching, the social scientists have indicated that's probably helpful. There's every time you change something, you lose some people along the way. So you have to kind of gather them back in, and time is of the essence. You may not have the time to do that. So if we can minimize warning label switching during an event, I think the policy we got. And the other thing I learned along this discussion a year or two after Sandy was that it actually brought us into alignment with Canada. Canada was doing what the Weather Service has been doing since 2013 is what Canada was doing before 2013. So I guess that's a good thing too.
Mm-hmm. Well, it's not
and I think it helped.
People. Sorry, Dave. Go ahead.
Yeah, it helped this focus on impacts, right? So whatever, you know, the atmosphere hates to be put into a into a category, right? So, but you know, this focus on impacts is just is so important, and you know, really where we are now. But yeah, but the flexibility, you're right, Gary, with the policy change, I think that's been very helpful as well.
Yeah, it's a paradigm shift, and I hope that our non-NOAA folks on this webinar understand that it was a big area of discussion. It was a big concern, and they knew, you all knew that it needed to be addressed, and you took the steps to address it. But these things can't just turn on a dime, right? You can't just make a cruise ship pivot in the middle of the ocean. You know, the government weather service is a large vehicle that needs, you know, time to be steered in a different direction. But you know, it's not just what I was going to say before is that it's not just the people, but you know, insurance companies making sure that people are able to get relief monetarily because of the way that the storm is categorized, all that kind of thing too. And one final thing I wanted to say before we go to our questions from the audience is Gary talked about the investment from Congress after Sandy to help kind of shore things up, modernize some things. The investment that Dave talked about that got our modeling improvements, at least initially. A lot of that came from you know, the Congress allocating extra money. The return on investment that we get from the government weather entities getting more money is it's far superior than so many other government programs. You know, for what we spend at Chipotle to get our lunch, you know, during lunch hour per year, you know, is practically the entire budget of NOAA. So it is definitely money well spent. All right, so I'll head over to our audience questions. First one here from Ronald. How similar and different was Superstorm Sandy to the quote unquote perfect storm, which I think was 1993? Anyone have any thoughts on that?
Well, that's a great question, mainly because actually I was just looking at that earlier today in preparation for this. I'm like, so what else? But this will be, there's no way for me to say this without sounding critical. I think it was a something of a shortcoming for the weather enterprise as a whole, that when we saw the perfect storm and we saw this sort of an unusual, atypical interaction between a tropical system and a non-tropical system, an extratropical system, that we didn't anticipate, okay, what would we do if that happened 200 miles off New England or 200 miles off the Jersey Shore? You know, I heard about the perfect storm and the impacts mainly in terms of, you know, very big long period swells that affected New Jersey and adjacent areas when I moved here to the Mount Holly office for the National Weather Service back in 1997. That was kind of my spin up on learning local marine you know, sort of history. The perfect storm came up. So yeah, I mean, that's how I think there is a lot of sort of technical similarities between the two. I mean, they're not a perfect match, but the way they behave, this transition, I have two sons who are now adults, but back when my eldest son was like a teenager, he asked me if a hurricane could have, we moved to the East Coast, he asked me if a hurricane could have snow. And I said, oh no. And then after Sandy, he remembered, like, this is like 10 years later, he remembered, and he's like, Dad, you told me, and now I see a hurricane with snow. So I said, yeah, I'm gonna back that one off a little bit. So yes, I do think that was an opportunity to learn things that we missed. I hope to keep those at a minimum, because I certainly could have raised the issue as well as anyone else, but I did not put two and two together on that one.
I'll just briefly mention Fiona and its path as it went into Southeast Canada had some similar Sandy-esque a bit in terms of the upper low and how it kind of got captured and then pulled back towards the northwest. So that, I mean, that was just a month ago. So again, the atmosphere can do these things, right? I guess that's kind of the point here, and just an unfortunate alignment in a bad way with Superstorm Sandy. That the east coast of North America, with over 40-50 million people in its path, that happened there. But yeah, these blocking patterns, that I think about the perfect storm. I mean, there was a blocking pattern. I was in the Midwest and was in a blizzard of 1990, the Halloween blizzard of 1991. So trough there, big ridge, and then the other trough with the perfect storm. So these blocking patterns can be trouble.
And thank you for the correction there. It was 91, not 93. Perhaps I'm thinking of Blizzard of 93, which is my first memorable event as a youngster wanting to get into weather. So our next question comes from Leonard. You know what? I want to say that we already answered this one. Do you believe that the media can do a better job at educating the public as to the tools being provided by the National Hurricane Center? Maybe we didn't answer that question. As a media person, Leonard, I can say yes. Each of us is, in charge of our own messaging, and I do what I can to provide that. Now that I'm off camera, I always encourage my team to do that. And I think that that's, especially since the day-to-day forecast, like what temperature is it going to be at what time, you get that from this. So what value do we bring when we're on the air, when we're on television? And these are the different ways in which we can bring value. So I think that that's absolutely something that we can do a better job at. By the way, for anyone on this webinar who has been to Manhattan and maybe noticed something that you don't see overhead power lines. Why is that? It actually dates all the way back to 1888, a blizzard that brought snow drifts. I forget what the tallest snow drifts were reported, but they were way over people's heads. And you see the photos from back then, and the power lines are like mesh over the buildings and everything. Massive destruction to the power system that was still very nascent back then, right? All the way back in 1888. And at that point, the decision was made that we've got to put these lines underground. And so that is why specifically that borough does not have overhead power lines. So a little fun when weather made history fact for you there. So our next question comes from Michael. And Michael is with the Lawrence Berkeley National Lab, and he uses the word hour. So I'm going to assume that this is something that they did at his facility. In our Sandy hindcast simulations that made the turn, we found that relatively small perturbations to large scale conditions caused the storm to go out to sea. So how much of the difference between the US and Euro models are due to change in initial conditions? Was the way that initial conditions are fed into the GFS inferior to the way that the initial conditions are fed into the Euro? I've heard a little bit about this from Neil Jacobs, but curious to see what you all have to say about it.
Yeah, I can take this. Yeah, in preparing for this, I kind of had the same question, right? And so as you kind of look at the literature, there isn't there's kind of competing different ideas. Some papers show the initial condition issues. Some papers show that just a simple adjustment to the convective parameterization of the GFS with the same initial conditions that it had would have helped the forecast. So I think with all things modeling, sometimes it's not just one thing. It can be a complicated answer. I mean, there's the question about just predictability as well of this event. But listen, it is recognized that I think it's the 4D VAR data assimilation system that the European Center has, it is generally, I think, where the science is headed. And so, how you take the vast amounts of data we have from satellites, other observations in situ and remote, and how you transform that into initial conditions for a model is a critical process, right? So, part of the efforts with EPIC and kind of the modeling efforts here in the United States is really to help improve data assimilation. I think
Dr. Novak,
I just mentioned
what is EPIC?
Oh, you're gonna put me on the spot there.
The Earth Prediction Innovation Center. There you go.
Okay, wow. And so it's a way to organize the community to really make the very best modeling system in the world, working together with academics, developers, different labs such as the Berkeley lab there, and really address some of these hard modeling problems. But yeah, I think a lot of the scientific field believes data assimilation is a key part. But it's the jury's still kind of out on Sandy a bit. It seems a little it could be that, but there's some other scientists that have made tweaks to the GFS physics schemes, and that was enough. So I think the main point is better initial conditions, better data assimilation, better model formulation. All of these things help make better forecasts, which then humans can help express the impacts of these forecasts and help decision makers make the very best decisions to save lives and property. That's the value chain. Yeah.
Excellent. Okay. I want to just kind of stay on the topic of modeling and forecasting, since I see a question about, so the question is it assumed that Sandy's intensification in southern term was related to a sudden dip in the jet stream? So to what extent was that upper level low coming in from the west a factor in Sandy's sudden term? I don't think intensification is necessarily what we're going for here, but you get the idea.
Well, I'll say it certainly seemed to increase the scale of the storm. I mean, Sandy was very atypical. By the time it made landfall in terms of the wind field, there wasn't this close, to the center focus of strong wind. Some of our and associated surge, some of the highest surge was significantly north, of the surface circulation center. Our highest tide gauge in terms of surge number, value above normal values was up at Sandy Hook. So I think that upper low, that transition from a purely tropical system to a post-tropical or a coastal storm, for people in New Jersey, that was all part of that the upper low coming in and triggering the transition. I knew just one other thing. I knew we were in like a different realm. I knew we were in a different realm for days and days, but on the day Sandy was going to make landfall, before the hurricane advisories go out, there's a hurricane conference call that the weather offices are on to just discuss what's going on and to line up if there needs to be any changes on watches or warnings or anything else. I remember the Hurricane Center forecaster on the line briefing said there's a hurricane hunter in the southwest quadrant of the storm, and so this would be down like close to the Carolinas at that point, out over the water. And they said they're like at 5,000 feet or whatever, and they're reporting snow, and so just once again, I said this storm is just, it hasn't even made landfall yet, and already it's got snow, in it. So that just, again, the merging of the upper low feature with a tropical system resulted in some very dramatic changes. And again, for me, the biggest dramatic change was the scale of the storm, which resulted in bigger storms.
Erica, I think I could show a slide here real quick here. Let's see here. How do you do that? Here you go. Whoops, what did I do? There it comes. Just kind of the evolution of, this is the pressure of the storm, and you can just see, so you got the satellite imagery across the top here of just kind of the different evolution. I mean, this is a classic, hurricane here, right? As it made Jamaica landfall and Cuba landfall. But actually the lower pressure, was just off the Jersey coast, you can just see the upper trough kind of digging behind it and capturing the system. And you see how large a scale this, as you get to the right side of this was. So yeah, it actually, I guess it was both. It was both the size and the intensity that, the trough, if you will, in that interaction, it actually did deepen it as well.
Yeah, perhaps it was unfair of me to say that maybe intensification wasn't the right word, because I always think of like deepening, right? But the lowest low pressure is generally analogous to the intensity of the storm. So my bad in the way that I framed that question.
I mean, it's crazy to think of a 941 millibar observation in New Jersey. I mean, it's just wow.
Yeah, it's bonkers. I mean, and to get snow on the backside of it, feet of snow. Yeah, there was certainly an anomalous storm in many respects. So we have a couple questions and we only have a couple minutes left. So there are a couple questions, and I'm sorry that we're not going to get to everyone's questions, but there are a couple that kind of rotate around this idea of preparedness and lessons learned. And we have talked about it a little bit, but why don't we just kind of wrap up with all three of our panelists saying, if there's one thing that you could change about the way that your team handled the storm before, during, after, what would that be, or what lesson did you learn?
Well, I'll go ahead and start. I mean, just to focus on impacts again, going back on this, was a hurricane or not a hurricane? One of the things that I did a lot of presentations post Sandy, both to government officials and just a lot of general public requests and I said, if there's 8 feet of storm surge coming, it doesn't matter whether it's caused by a nor'easter, a hurricane, or the Martians. It doesn't matter. Don't move away from the label of what's producing it, and focus on the 8 feet. If you're going to be flooded by 8 feet of storm surge, you need to react to that. So I think that was one of, just going back to, again, the overall focus. Sandy reinforced it. I think we pushed it during the event, but certainly after Sandy, the focus on impacts and the briefing packages from the National Weather Service. People like labels, like a little science, and that there's nothing wrong with that. But impacts is now the premier thing. Was after that, and I think that still continues to be the case.
Gary took my answer. Yeah, I'm going to double it with that's great. Yeah, the focus on impacts. I will say, I mean, I think it is important to note. I mean, I think the New York City subways had closed in advance, and there was a proactive action that saved many lives. But yes, this focus on impacts, I think and I think you've seen over the arc of the last decade how really the federal government has, Weather Service leading the charge here, making that adjustment. Yeah.
Mm-hmm. I think it's good that you are in agreement about this, because it means that there's some continuity there and real action to move forward. Excellent. Well, thank you so much to all of our panelists. I'm just really thrilled that we got to have this conversation, and I hope that everyone in attendance learned a lot today. And I'm going to hand it over to Gideon again, our AMS staff member on the webinar, to wrap things up for this evening.
All right, fantastic. Well, David, Gary, Ornella, Erica, of course, thank you ever so very much for everything. Yes, viewers, I think that's all the time that we have for today. Please keep in mind, though, that we will make this video available to Weatherband members at amsweatherband.org and at ametsoc.org. And viewers, if you have further questions or if you want to discuss anything about the webinar, you're always welcome to join us on the Weatherband Community Forum and post those questions there. And get some input. So with that being said, panelists, guests, thank you all for joining us today, and wish you a wonderful evening. Take care.